So we now have our chessboard, but this is kind of boring, right? We could go ahead and make chess, but that's going to be a very long tutorial to go ahead and make a chess game, but feel free to go ahead and do that challenge. But what I want to do is just make our chessboard a little bit more funky and respond to mouse input. Kind of like what we have here, where what you can notice as I move my mouse, I am making either the squares go bigger and smaller, or making them rotate around like their center point. And it just looks pretty cool. And you can imagine, if you understand how to do this, you could do a lot more cool stuff. Replace it with circles instead of squares, and triangles, and different types of shapes, and different colors. So think of this as like equipping you with the tools to create other very cool designs. So the way in which we are going to do that, in order to create that kind of effect, is that we need to use transformations, right? Those transformations I'm talking about are things like translate, rotate, and scale, right? Translate changes where our origin is, where our 0, 0 point is, and everything is drawn according to our 0, 0. Rotate then changes like what angle everything is at, and scale makes everything either bigger or smaller. Those are the three major transformations. Now, let's just imagine I wanted to rotate everything according to my mouse, right? So as I move my mouse, let's just play with this rotate function and see if we can't like figure out how to get it to work such that we get this effect. So I'm going to say rotate, and inside of here I'm just going to put mouse x, right? Mouse x is a global variable that keeps the x position of my mouse. And now notice what happens when I do that and I move my mouse around the screen. The whole kind of screen rotates, kind of looks like a Finnish flag, which I think is pretty cool. So, okay, we get that, but what I want you to notice is notice where it's rotating around. What is the axis of rotation? It is this top left corner right over here. That's where it's like I kind of have my finger on that point, and then I'm rotating it around that point. So, okay, and now the next thing I want to show is I'm going to change my translate. So I'm going to put translate, and I'm going to put this at like 300, 300, or whatever. Right, so that means my new 0, 0 point is at position 300, 300. And notice what happens now. Where I'm rotating is around that new point. Right, so the rotation always happens around the 0, 0 point of our axis, right, wherever this is occurring. So then the idea might come to you to be like, okay, what if we translated every time when we're drawing the rectangle and then rotate? Let's try it. Let's copy paste that. We can put it over here, and I'm going to put translate. I'm going to put, now I want to translate to where my rectangle is. So I'm going to say translate X and translate Y, and let's see what happens. Oh, okay, you might have already seen a sneak peek. So look at how crazy this looks. I don't even know what's happening. This isn't a chessboard. It looks like somebody is throwing paper up in the air and having a party. Looks pretty cool. But the reason why this is happening is that translate is adding on to itself every time, right? So when I say something like this, if I say translate 200, 200, and then I say translate another 200, 200, these two effects are added on top of one another. So this one isn't the same as just saying translate 200, 200 as if this wasn't there. With these two effects in combination have the effect of saying translate 400, 400, because they get added on. So now when we're translating inside of the for loop, we're translating every time. So we're adding on every translation. And similarly, we're adding on every rotation. The way we can fix this is by using push and pop. We can say push over here, and we can say pop over here after we're done drawing. What push does is it says, okay, save the current state that I'm at, right? So whatever transformation state is here, save it, and then restore it, right? Restore it over here. So that means anything we do inside of here doesn't affect, it doesn't get added on, because it's essentially reset, right? It's the same as saying translate minus x minus y and rotate minus x, push and pop. So that's what that effect does. And now we get a cool thing. I think it's as well, we want to get rid of this, but that does look really cool. How did we get that? Oh, where is that? That looks pretty cool, no? I really dig that. Okay, regardless, hopefully my face isn't blocking it, which it was, but you can see it kind of there. Let's get rid of these translates over here. And we still haven't solved the problem quite, right? We can still notice it's somewhat more predictable and it's following a more orderly pattern, but it's still not quite what we want. And that's because we're still drawing the rectangle at xy, right? We've moved to xy, and then we're saying, okay, draw this rectangle at xy relative to this. So we need to put this at 0, 0. And the same with our text over here. We can get rid of text, in all honesty. Okay, we now have our grid back when we go 0, 0. And now notice what happens. Again, like, these are cool effects and you can play around with this a bunch. But the reason why this is happening is that let's maybe choose, I wonder if black's the right color because our background is black. Maybe if we go, let's brown. Will that look better? I don't think so, but we can see. Kind of. It still has the same problem. Let's just stick with white. But you'll notice this is still not quite the effect that we have here. And what you'll notice here is that where this is actually rotating around is the center of the square, right? We're not rotating. What we're currently doing is we're rotating around the top left corner of our square. We want to rotate amongst its center. So that means we need to translate to its center. In order to do that, we need to change something. So currently rectangles are being drawn according to the top left corner. We can change that and have rectangles draw according to their center. The way you do that is say rect mode center. And now these rectangles are going to be drawn according to their midpoint, not according to the center. But now you'll notice everything is kind of rotated or pushed up to the left here. That's because we're still starting at 0, 0 over here, right? Which is the top left corner. If we're drawing each rectangle at its center, we then need to translate this all over. This needs to become square size over 2. And so too does this one. Square size over 2. Okay, and now we get that effect that we were looking for. So or rather it's fixed. Now the question is, oh, do you know why this is actually working? It's colors. It's colors that's causing us. So let's just go ahead and copy the colors that we have here. Full white and full brown. This might actually make it a little bit better. Okay, there we go, okay? Because what was happening previously is that you couldn't tell the difference between the background and the foreground. But now all of a sudden we're getting the effect that we were looking for, where we can move our position left and right, and we're now rotating around the center of the square because we've changed where we're drawing our square, not relative to the top left corner, but relative to its center. And now we're translating to that and rotating around that point. Okay, it's looking cool. Last one is now scale, right? So we want to scale this according to the Y position. So we could just, inside of here, we can just say scale. And now what I'm going to say is mouse Y. And let's see what happens when I just say scale mouse Y. What we notice is that we just get like one square, right? And then there we can start to see all kinds of cool things happening. What is happening here is that our Y value gets really big. And so our grid consequently gets really big, which is not what we want. We don't want, we want a maximum that this can be, because our mouse Y can go up to 500, and we don't want to scale. When we're saying scale 500, we're saying make everything 500 times bigger. That's not what we want. We want to maybe say make everything between 1 and 2 times bigger, or 0 and 1 times. So the way we could do that is by dividing by our total height, right? If we divide by our total height, and the biggest that mouse Y can get is 500, then it will never get bigger than 1. So, because when it gets to the bottom, the height is 500, our mouse Y is 500, 500 divided by 500 is 1. So if I say mouse Y over height, And now, all of a sudden, we get a much nicer, smooth picture. And when we get all the way to the bottom here, we are getting the full-size kind of grid. And now we're getting the effect. And it really was that just simple with doing translate, scale, and rotate in order to get that kind of effect. What we're doing here, funny enough, is something called normalizing. Right? So this is a math topic which essentially says take any variable or take a number, take a number between like 0 and n, right? Where n can be anything, n could be like 1,000, and map it to a number between 0 and 1. That's what normalizing is doing, and that's what we're doing with scale. We're normalizing mouse Y between a value of 0 and 1, instead of being a value between 0 and whatever the height is. Okay, that's the chessboard. That's some cool stuff. You guys can go ahead and play with some color. Maybe get a color to go on each one, so that like each point goes yellow, then yellow, then yellow, then yellow, and kind of goes through the entire grid. Get it to go in a wave. There's a lot of cool stuff you can explore, but I'll leave it here. Thank you for joining me in building a chessboard.